Hello everyone. Myself is Ravi Kumar and I am from MIT Academy of Engineering. I did this IoT internship at Emergy where I have done this project. Now I am going to show you what I have learned this internship and this project. So let's start. My project is home automation using IoT. This my project will look like this. That is, home appliances will be controlled using an app through internet like LED, heater, cooler, fan. Now I'm going to show you my table of content. First is introduction, second one is objective, third project stages, fourth methodology, fifth project design, and sixth and conclusion. Now introduction. When you would hear this name home automation, you one question arises in your mind: what is meant by home automation? First, you will know that automation means something that will work automatically. So home automation means something appliances of home that will work automatically, like LED will on in night, LED will off in day automatically, like this, and heater will on off automatically according to temperature, like that. In this project, I am going to control LED, street light LED, then heater, cooler, and water tank. And I am going to monitor this and present this on a LCD. Now, what I have learned during this whole internship. First, I have learned is C programming. Second, I have learned is microcontroller. Third, I have learned is embedded system. Fourth, IoT, that is Internet of Things. And fifth, I have learned Blynk app, which I will use for IoT communication. Now, what I have learned in C programming. Then first, I have learned in C programming, like introduction, who has developed this and who has used first C programming. Then data types, modifiers and qualifier. Then modifier means signed and unsigned character, unsigned type, and qualifier means constant type or volatile type data. Then conditionals like if else conditions. Then loops. Then I have learned operators, arrays, pointers, function, and storage classes. In storage classes, I have learned memory segment. In memory segment there are four segments: data segments, text segment, stack segments, heap like. And then at the end in C programming I have learned preprocessor. Preprocessor always use with hash defined. Only we can use preprocessor using hash defined, like hash when we include file like hash include stdio.h, that is preprocessor directive. And when we use hash defined, then we are going to define something as a something. Then I have learned microcontroller. Now first, what is microcontroller? Microcontroller is an integrated chip which has a ALU, that is arithmetical logic control unit, which has ADC block, that is analog to digital converter block, which will sense the analog signals and convert into digital signals. Then it will process that signals. Then it has DSC block, that is digital to analog converter. Then it has timers for generating pulse and creating delay. Then it has PWM, pulse width modulation, for controlling the intensity of LED and for controlling the direction and the speed of a fan. Then it has a processor which has all the control function like ALU, like that, and it has memory where we install where we burn the code like flash memory. Then it has RAM. At the end of microcontroller, I have learned what is the main difference between a microprocessor and a microcontroller. The main difference between a microprocessor and a microcontroller is that microprocessor does not have any peripheral. Peripheral. It does not have built-in RAM ROM. It has only control in it. While a microcontroller has all it has their own memory or on chip memory like RAM, ROM, and they have input output peripherals, so we can easily connect any sensors to that. Then I have learned embedded system. In embedded system, first, what is meant by embedded system? Embedded system means a system which comprises with hardware and software and which will perform a specific task. And there are four types of embedded system. First, standalone. Second, real-time embedded system. Real-time means that will work on real live. That is, for example, for an example, our GPS is giving location live and in real time. Then third one is network, and fourth one is mobile. And third, what are the components of an embedded system? Then embedded system are obviously some hardware, some software. Then hardware required for embedded system is control unit, either microprocessor or a microcontroller or a system on chip. Then ADC block, DSC block, memory segments, and human interface like that. And requirements of this embedded system is that it is more reliable, it is cost effective, it is if we get in less cost, it is low power consumption, and it is fast processing. That means when we give input, it gives output fast. Then I have learned IoT. Now, what is IoT? IoT means Internet of Things. Everyone know that IoT means Internet of Things, something that will work on internet. Then, what is background? That means is a unique object that connects to internet. It only connects with devices, not people. That means I can't connect or people to another people through internet through IoT. That means only device can get interconnected, like embedded when we connect embedded system with internet, then it is an IoT. That means data will be transmitted through internet of that embedded system. Then it is bidirectional communication. Now, inflection point, technical requirements, and what are the challenges nowadays IoT is facing, and first principle. Now, inflection point. Inflection point means nowadays hardware is getting cheap as compared to earlier. In nearly 2006 2005, the when you buy the laptop, then the price was nearly equal to lakh. But nowadays the price of a laptop decreases so much decrease, and now we get a laptop in nearly 20 to 25,000. And machine to machine solutions are mainstream. Connectivity, software is more advanced nowadays, and the cloud cost scale is flexible nowadays. This is inflection points. This is all. Now technical requirements. Technical requirements like for large scale communication, we require large devices. We require a good security, end-to-end encryption, so data should not get lost, and no one can theft our data because it is our personal data. So we should keep end-to-end encryption. Then volumes of data would obviously data will store in large volume because large things are getting connected to cloud internet. Then end-to-end encryption. Then challenges is that first one is connectivity. That is connectivity not proper at every at every places. Like in our country, in villages, there is no proper connectivity, no good internet. So we can't send the data good at that places. Then scale because we are sending a huge data, and for storage the data we require large memory. So large memory we require large hardware that to store that data in that memory. So we require a large scale. Then first principle means addressing a scaling connectivity like that. Now Blink app. Blynk app is an app which is used for IoT. It is a general app which is built for using IoT, which is used for communication, which has a Blynk cloud server to which we connect devices to internet, and we can control that devices. In this Blynk app, I have learned how to create template, how to add devices, how to select and add data stream in this, and how to include Blynk library. Now come to next. This now objective. Our main aims of this project is to control, to create home automation. First aim is to create home automation system. Then to control cooler and heater remotely through internet. Then to control the LED during day and night. Then to control the water tank. That like Then project stages. First, I have done C programming at first stage. Second, microcontroller. Third stage, embedded system. And the fourth stage, IoT and Blink. Then our project got ready. Now, methodology. That is process flow. How our process will look like. This is the block diagram of process. Here, Arduino, one development board, one LCD for showing and showing current situation, current condition for notification, and one temperature system. Now, Arduino, what will it do? It will sense the all system and it will send data to Blynk IoT. And Blynk IoT app will going to control this. Blynk IoT will send a command through which Arduino receive, and Arduino will turn on or turn off the heater. If Blynk IoT send a command to turn on the heater, then Arduino will turn on and turn off like that. Then project design. Now, what are the requirements of this project? First one is hardware requirements. In hardware requirements, we require LDR sensor, that is light dependent pressure sensor. It will depend on light increases and distance, like increases or decreases like that. Then one LED, then Arduino Uno board, which has on-chip Atmega 3 to 8P microcontroller. Then one LCD to displaying all the notification like temperature increasing, decreasing, water tank flow, like inlet on, inlet off, like that. Then one LM35 temperature sensor that will sense the analog temperature value and will be displayed on LCD. Then heater and cooler, and then an Ethernet shield. Ethernet shield will connect the hardware to the internet, and through that we can control these devices through internet because of Ethernet shield. Then in software requirements, first one is Arduino IDE for programming all this. Then Blynk app for communication, for controlling virtually or remotely. Then internet, the most important is internet. Without internet, nothing will going to happen. Then this is a project because I have created this, so I have displaying that created by Ravi. Then our project will look like this. Like temperature is 27.33 and water tank level is 2270 and inlet is off in one Arduino Uno and LED is on as a light sunlight is off like that. It is evening time.
I am going to show you the demonstration of this project. So I am going to opening PICSIMLAB. I am going to open spare parts that I have used: LCD, Ethernet shield, LED, LDR sensor, temperature system. Uh, Now I have to debug. First I have to include serial mode tank. Then I have connected. Now I am debugging. Now inflow automatic get started. Here you are able to see that inflow is increasing. It will increase up to 2000. Then we have to stop that. So I have stopped. Now I can outlet on. I can stop. Then now I am going to show you the how heater will work. Now I am going to turn on the heater. Heater is turned on. Here you can see that heater on displaying on LCD. If heater is heater temperature gets greater than 36 degree, then it will send a message on virtual terminal that temperature is greater than 36 degree. Then heater will get automatically off. Now I can use cooler to fast cool down the temperature. So I am using the cooler. Then temperature will decrease rapidly down. Now I am going to show you the how the LDR sensor will work. In daytime, no, in daytime sunlight is present, so LDR LED will off. In night time, as we increases, light will getting on, and at night it will get maximum intensity. This is the project, and the code I have used is, since I have already burned the code into that, so I not show you code initially. Now I'm going to show you code. Code is this. I have included serial peripheral interface module and internet library file, then a liquid crystal I2C library file. Then I have declared ld ldr.h file, main h file, where I have declared all the I have defined all the temperature gauge, like cooler pin, which pin connected to which sensor. Then in serial tank I have declared how it will work. Then serial manage tank.h. Then temperature system file, in which it going to read the temperature and control the cooler and heater. And temperature system, we have declared float read temperature void initialization temperature system, like that. Now I am going to conclude that from this project I am able to use Arduino easily, and LDR sensor, LM35 sensor, and LCD. How to configure LCD, how to use LDR sensor, how to use ADC block for sensing the analog signal. I also know how to app for IoT for sending data and receiving the data on cloud, and how to do automation using Arduino. How we can use Ethernet shield for connecting the Arduino to the internet, so we can easily send the data and receive the data from that Ethernet shield, and hence anyone can control their homes through the internet remotely from sitting anywhere. They can easily control their home like LED cooler, fan, etc. Thank you.